Okay, in this video, I want to introduce to how to interpret and go about the results that you get from the Aegis introspection engine. Now, there are a couple of areas that needs to be looked into. Now, first of all, um, in here, you get the number of distributed call graphs that has been analyzed for latent vulnerabilities, and that gives you a sort of solid foundation onto how many different parts that are available in the system, and therefore what are all the different ways that a system could get into having vulnerabilities. Now, the second of it is the average probability expectation. Now, this is a weighted average of the probability of the system being secure. Now, a low average probability expectation is an indication that the system as a whole has a low probability of being secure, or in different words, it basically indicates a higher probability of being exposed to different vulnerabilities. Now, uh, 0.2, even though this says 0.217, now this is calculated based on the base rate. Now, 0.5 is the default value that we set here. Now, this is um, um, a base rate of 0.5 basically means that you're balancing equally between the belief the system is secure and the disbelief the system is insecure. Now, depending on the appetite for risk, the architects or whoever is responsible for the system can change the base rate so that this would go. So the average probability expectation and the critical finding number might change based on this one. Now, for example, if you reduce the base rate, that is an indication that you are putting more weight onto the disbelief side of it, whereas you putting the base rate into 1, which means that you are more confident or you're able to take uh, in more risks. Now, based on that, the critical number of critical findings change. Now, this is corresponds to the parts which are believed to have low probability expectations, and therefore that would be classified as a critical finding. Contextual conflicts means whatever the parts which has expectation values which falls around 0.5, so which means that there are not enough evidence to show or even calculate either the belief the system is secure or the disbelief the system is insecure. So we are simply saying that there are 45 distributed parts which does not have enough evidence to really properly recognize either being secure or insecure. Now, these are areas which obviously tells you a quick indication to tell an architect or even a programmer to so okay, there are not enough security related implementations or enforcements within these graphs. Now, there are obviously two uh, dot plots, I would say, that 2D and 3D. Now, these are exactly the same graphs, but in two different perspectives. Now, this says the same thing. Now, this plot basically shows you the belief, the disbelief, and uncertainty. Now, the uncertainty is what I mentioned of not having enough evidence to to assess whether the security or the insecurity. Now, anything that in any of these axes, if a dot falls around 0.5, that is an indication that there might not be enough evidence on either of these cases. Now, for example, in an extreme case, points that are much closer to the center is actually where you don't necessarily or not really find any sort of evidence to put those paths in any of those quadrants. Now, if you look at train ticket, so this is analyzed for train ticket. Now, most of these seems to be uh, put into this corner. Now, if you look at uh, the numbers, now you would see that these points are much closer to the disbelief of 1 and the belief towards 0. Um, so which means there is more evidence to show that these paths, each of these dots are indicative of a distributed path. There are more evidence to show that there is evidence which could lead to probable latent vulnerabilities. Whereas if you go towards this side, there are more evidence to indicate that the distributed path is in fact much more secure compared to the paths that are placed here. Now, using either of these graphs, you can click on them to recognize or identify what is exactly this distributed paths, what are the latent vulnerabilities, and also what are the evidences outlining these findings. Now, for example, I've took this distributed path which starts from the price service slash price. This is put in point, which calls update price config and then calls find by ID, which then updates the price config data entity. Now, in terms of evidences, there have been 4 neurocentric evidences to indicate that this path has or has signals or has features that could lead to vulnerabilities, and there are also 2 safeguards as well. Now, as a result, if you put all this evidence together, we could see that there are 1, 2, and 3 latent vulnerabilities that has been identified. First of all, being the unauthorized updates, which is a result of this endpoint being marked as being public and being allowing on unauthenticated access as well. Now, this comes as a result of also analyzing the entity underlying this data and also the attributes, which might have signals to show that these might contain some information or pieces of data which might actually be exposing some of the information of the system. For example, you could see that in the second latent vulnerability that has been identified, that this is actually related to a field that is concerning price config. Now, again, you can see that you're actually pointing towards a possible injection vulnerability, because we recognize there are sensitive information that is being exposed and there is no proper validation either on these properties. So, which means that this path could potentially be vulnerable. Now, you could also see these for any other path as well. But now here too, compared to the last path, you can see that this is a little bit more longer and there are more risks being identified, but there are less number of safeguards as well. But you can see that maybe due to the fact that these safeguards are much more stronger than the risks that has been identified, this path has been classified to be much more safer than the one that we discussed before. Now, but we do find that there is a possibility of an injection attack and also sensitive data exposure as well, based on the features that we have recognized based on this path structurally, and as well as based on the code and other semantic elements as well. So, and you could also see that we are pointing to the particular location and also which could be triggering these particular issues, as well as we are also recommending the recommendations as well for each of these paths. So which means that you for an architect or any sort of a practitioner who is involved in the system doesn't need to really analyze these parts manually, or to uh, do any guesswork to assess what are the root causes, and also the remediation actions that needs to be taken. And also, since these parts are already prioritized based on the expectation values in this graph, you could basically start from the parts here and move on to parts here, which because these parts are the ones which are more insecure, potentially exposing the system to vulnerabilities, whereas the parts that are more closer to the belief one are the ones which are naturally more consistent, and are not really the ones which could are at the most risk of exposing the system to vulnerabilities. Okay, so this is how you would want to use Aegis. Now, obviously, there are more improvements that we could do. I'll introduce those in a separate video later on. Thank you.